Hello everyone and welcome to the aTech channel. Today we're going to look at induction charging for electric cars. It may sound utopian, but research is moving in that direction. Most of us take it for granted that we can charge our phones without plugging them into an outlet. But what if we could charge our cars like this? The same way. No need to think about plugging in your electric vehicle. When you arrive at work or drive home, without even having to think about it, your car could always be charged and ready to go. Many advances have been made in the last couple of years on the subject. Induction charging has been around for a long time. However, charging an electric vehicle is a whole different matter. We're talking about magnetic resonance charging, and that's what Witricity has developed for electric vehicles. Alex Grusin, Witricity CEO, magnetic resonance is a wireless energy transfer option based on induction charging. The pad on the ground and the receiver that's built into the car are both tuned to the same frequency, around 85 kHz, to make it work. Each of them is a very efficient harmonic resonator. The energy moves efficiently between the two. Unlike traditional induction, any offsets or mistunings do not impact magnetic resonance. The question is whether that will happen in the real world. The big hurdles to bring wireless charging to the market have been ratification of a standard. For example, Witricity worked for SAE, an international G2945 standard of wireless charging. It took no less than 10 years to unblock the issue raised. Therefore, Witricity is mainly concerned with technology transfer and licensing during these first years of existence. But the goal has always been that as the market develops, vehicles will come to the market with this technology integrated. Witricity will bring its own products to the line market as a proof of concept. For example, they have equipped existing electric vehicles with wireless charging. They have worked on the Ford Mustang and Tesla Model 3, among others. It is difficult to design an upgrade for a car that is not originally designed with wireless charging in mind. You have to consider the space available and be able to hide the charging station and equipment under the car, not to mention the safety protocols of the charging system in the electrical system. While the car is charging, they've implemented software that prevents the external charging door from being opened. For good reason too, it's technically powered up, even if you're not physically plugged in. If you simply pry open the door, the wireless charging system automatically shuts down. Nevertheless, they've independently developed aftermarket replacement kits. The core of their business, however, is that they always have been able to enable car manufacturers to design wireless charging from scratch. To do this, they partnered with Hyundai on the Genesis GV60, currently available in South Korea. Displays and cameras built into the car are used to guide the driver to correct charging position, so the car parks and charges itself. Following this first successful partnership, they currently develop more partnerships. Already integrated in the Tesla Model 3, they had to add a secondary screen to give the driver real-time feedback. All of this is still a work in progress though, not the final user interface. For now, they're focused on the functionality. The most impressive thing is the level of precision and aligning the pads to within a meter. Obviously, they're not going to show millimeter readings in the final product. It's just for development. But you can see there's a good amount of leeway on the alignment. For charging speeds, it's comparable to what you get at home. It's a 1 kilowatt charger that can add about 56,000 miles per hour to your car. But there's an important point to make about speed charging and efficiency. 11 kilowatts is not the limit for magnetic resonance charging. It is the limit of the consumption model with building and release. Higher power solutions are being developed for the last mile, vans for the middle mile, trucks for the communicating, and for the transit buses. It's all about designing the system for specific use case. If you're targeting a use case for home or business destination charging, 11 kilowatts is an excellent target. But they can change depending on the use case. As for efficiency, it can be hard to pin down. If you consider the entire system circuit for the entirety of the battery, the efficiency is about 92%, which is about the same as a wired charger. There are two other use cases that are unlocked with this technology. Autonomous parking and charging of cars are where it's all headed in the future. If you remember, a few years ago, Tesla experimented with a snake-like robotic charger that could automatically plug into your car. This is a fairly complicated solution for many moving parts and a potential to fail, in addition to maintenance. The wireless charging system avoids these problems completely. The second point unlocked is the connection of the vehicle to the grid. The electric vehicles that are coming on the market support two-way charging. This means you can power your home from a Ford lighting truck in the event of a power outage. The only inconvenient thing about the vehicle grid is that you have to remember to plug in to get your certain benefits. Beyond the power of the outage, with two-way wireless charging, not only do you never have to worry about forgetting to charge your car, but it provides a backup solution for your home. For most people, if the car's batteries are fully charged, they don't plug it in, and that's where most V2G is most useful. Even if it's not plugged in, the batteries can charge. And the cost of the system? The wireless power receiver that goes on the car costs about the same today as an onboard charger. It's between $500 and $700 for a car manufacturer to install it on your car. But it looks like it's possible to reduce the cost by a few $100s. So in a few years, adding wireless charging to your car will be a bit like adding modifications to your home. There are, however, many questions about the safety of the system. For example, what happens if a cat, crawls under your car? This is another one of those things that can be a little bit difficult to understand because the system operates at a low frequency that is very safe. This is based on the same principle as the induction cooktop. So there's a series of sensors to notice if a metal object comes near the plate and it shuts off. The same for your cat. If you approach the plate that transmits the charge, the system shuts off. So when can you get your hands on wireless charging for our electric vehicles? It's already in the market in some areas, but why is Ytricity trying to accelerate with new partnerships? Last June, Siemens invested $25 million in Ytricity to help accelerate development, and they see this as a multi-billion-dollar market. But given the slow paces of automotive industry, it may be several more years before we see this market develop in a meaningful way. If you enjoyed our topic of the day, feel free to like this video. To enjoy more videos like this, subscribe to the channel, and most importantly, leave us suggestions for future topics. Activate that notification bell to be among the first to see our next video, and we hope to see you soon on aTech.